Okay, this is solving a system by the matrix method and by Cramer's rule. We're going to do some homework questions. Now remember, this is all based on you having a lecture. This isn't a lecture, this is just review of the homework from this topic. So I'm going to give you a slight demonstration, at least go over a little bit of details here to get started. Remember, we need to create a matrix, and it's really creating an augmented matrix. So we got to create a matrix here. And by the way, this matrix is really shorthand for the addition method, or at least this technique is. The matrix method is really shorthand for the addition method back when you learned beginning algebra. So I'm going to underline this being the addition method, and you learned this in beginning algebra. What we're going to do here is just create a matrix, and in this matrix we're going to use the coefficients. Let's get this a little bit tricky to draw here. So let me do this here. Create these lines. And we're going to use the coefficients here of our equations. Now, these are the coefficients. I got a 3 down here. I got a 2 up here. There's a 1 in front of that x, and there's a 1 in front of the y. Now, this one and this one are also coefficients. We're going to use these values, and we're also going to use what they're equal to. All of these are going to go inside our matrix as entries. So you have the value 1, you have the value 2, the value -1, the value 3, the value 1, the value 2. We're entering every coefficient and the values that these equations are equal to into our matrix. Now, this is called an augmented matrix, and what that means for us is simply that we are augmenting this matrix with, this is my equal sign here. We're augmenting the matrix with what the values for which it equals. So these are the values here that we're augmenting this matrix with. It's not such a big deal to know the language with this at this point. All you need to know is you're going to simply enter every coefficient, and we notated that, and the values that it equals to, and make sure you put this line here, and that really separates the coefficients for the values that it equals. So this here is the matrix that we create from the system that they give us. Okay, so we have a system, 2 equations, 2 unknowns. First step is to create the augmented matrix, and here it is. Now, some more details. This is known here as the first row, and this is known here as a second row. We read that top row as the first one, the bottom row as the second row. This is also known, by the way, as the first column, as the second column, and as a third column. And every value that we see, the 1, the 2, the -1, I guess, the 3, the 1, and this +2, every one of these values are called entries. So we got a first row, we got a second row, we got a first column, second column, third column, and all the values are called entries of our matrix. So, okay, we have some language to work with here. And let's see if we can go back now and start to discuss what we really want to do here with this. Now, here's a game plan. Okay, so I'm going to give you the real plan here. Your plan is always to convert your matrix, augmented matrix, to another matrix that's equivalent. Okay? So you're going to convert your original augmented matrix to another matrix, and this second matrix is one that is known to be in row echelon form. So we're going to convert this to one that's known to be in row echelon form. That's our plan. And you say, what's a matrix in row echelon form? Well, a matrix in row echelon form looks like this. Here's our augmentation. I'm going to put an entry here. I'm going to put an asterisk. I'm going to put an asterisk. I'm going to put an asterisk here. This is just going to sketch kind of a picture of a matrix in row echelon form. But I want to emphasize that this entry must be 0. Now go back again. Remember, what entry is that? This is row 1. This is row 2. This is column 1. So we're essentially saying in row 2, column 1, at the bottom left, you must have a 0 value. And that is a matrix that's in row echelon form. So the plan is to convert this augmented matrix here. Okay? This is shorthand method. Convert this original matrix to one that's in row echelon form. Now let's erase some of these things and emphasize that this particular entry must be 0. And that's our plan. Now the next step is to say, well, how do we actually get there? How do we make that entry 0? Well, there's operations that I can use. So let me remind you here from the lecture. In order to do this, we're going to have to use EROs. EROs, they're known as elementary row operations. Elementary row operations, they're called EROs. Now we have three elementary row operations. Okay? Here's the first ERO. We can interchange any two rows. Okay? We can interchange any two rows. So if we go back to the original matrix here, again, I'm going to try to do this with an iPad here. You got 1, 2, -1, 3, 1, and 2. So the first example, I'll go through how to go with this process. Remember, this is row 1, and this is row 2. So to interchange rows, interchange simply means to switch. So to switch rows, I switch row 1 with row 2, or I interchange these rows. What that looks like to switch rows is row 2 is now row 1. We get 3, 1, 2. Row 1 is now row 2. I get 1, 2, -1. Here's an example, again, of how to switch or interchange rows. We switched interchange. Row 1 and row 2. That's what we can do. That's one operation. A second operation that we can do, okay, is we can multiply a row by a non-zero number. So this is the second elementary row operation that I could perform on a matrix. We're going to multiply any row by a non-zero number. So if I go back to this new equivalent matrix, and I want to say something here, that these matrices here, this first matrix, the top one, is equivalent to the bottom one. They're the same matrix. They represent the same system. So interchanging rows preserves this equality of matrices. Now, when they say to multiply by a non-zero number, we can still preserve the matrix if I just multiply a row, all the entries in the row, by a non-zero number. So for example, I might say, and I think it's good to recall that we use notation here, I might want to say, I'm going to multiply a -2 with row number 1. I'm going to create a new matrix when I do that. And it's going to be equivalent. So I'm going to take the first row. Here it is. Let's change colors here. I'm going to take this first row. And every entry in that first row, I'm going to multiply by -2. So -2 now times every entry in row 1, and I notate this right here. It reminds me what I'm doing. When I multiply a number to a row, if it's row 1 or row 2, doesn't matter. What's going to happen is every entry is going to change by that multiple. So the first entry is a 3. -2 times +3 gives me a -6. -2 times a +1 gives me a -2. And a -2 times a +2 gives me a -4. This is my new row 1. I can now go back and fill in the entries for row 2 because we didn't change row 2, we just changed row 1. Now again, another example of this could be if I take this new matrix that is again equivalent. All three of these are equal. They're the same system. As another example to remind you guys of what we discussed, we can say, well, what if we took +3 times row 2 now? Another elementary row operation. Well, I'm not changing row 1, so I'm going to write down the entries. -6, -2. This is augmented with a -4 there. Let's now multiply 3 times row number 2. So I'm going to multiply every entry in row 2 by that +3. Let's see what I get. 3 times 1 is 3. Over here, 3 times 1, 3 times 2, 3 times -1, and 3 times 2 is 6. 3 times -1 is a -3. So like I multiplied up here, every entry with -2 to change the values. I'm doing the same here with the prior matrix. Multiply 3 with row 2, and I get a brand new row 2. And again, these are equivalent matrices. So that's our second operation. As a really quick review of how to solve a system. Okay, and then step number 3, as this review, remember we already had the lecture. Step 3, the last elementary row operation is we can add any two rows together. So we're going to use the prior matrix to add, and let's see what happens here. I'll put that in red again. We can add any two rows together. Well, we only have 2 rows. So what I'm going to say here is, to get this next matrix, we're going to take row 1, we're going to add it with row 2. However, that brings a quick dilemma here, and here's the dilemma. If you recall, it's true, we can add 2 rows together. Row 1 plus row 2, we're really adding the entries. The question becomes, where do we put the answers? Well, like I mentioned in class, what I always do here is this. I put a star here. I always put the answers in the row that I guess comes second, if you want to call it that. In other words, I'm reading this as row 1 plus, this is where I put my answer, row 2, and I notate that by simply putting the answer, or I should say putting the asterisk there. It's kind of as a power, but it's not a power. I'm just notating that when I add row 1 with row 2, put the answers in row 2. And that's what I really think is important for people to realize, that what you're really going to change now is row 2. Okay? That is going to change. Let me go back here and emphasize that row 2 is going to change. Okay, let's see how that works. Let's go back and add our entries. So I'm going to take again, let's change color, -6 plus 3. And -6 plus 3 is going to give me -3. Where do I place the answer? Row 2. Next entry, +6 plus a -2, or a -2 plus a +6. Where do I put the answer? Row 2. +4. I'm going to take row 1 entry, -4 plus a -3. Where does that go? Row 2, -7. Now, since I changed only row 2 here, that means row 1 is unchanged. So I'm going to actually enter the entries here for row 1. That's -6, -2, and -4. But notice again, what I changed was row 2, and that's what I put the answers whenever I add any two rows together. I put it in the second row. Now, you might say to me, well, that kind of seems a little obvious, maybe. I don't know. But what if I decided to take row 2 and add it to row 1? See, we can add any two rows together. If that's the case, again, I put my asterisk here to simply notate that I'm going to have to change row 1. So row 1 is going to be new. And when I read this again, I'm going to add row 2 with row 1. And here's how this looks. I'm going to take the first entry in row 2, -3, and I'm going to add it with a -6. That answer goes in row 1. So -3 plus -6 is -9. I'm going to go back and add the row 2 entry with row 1, +4 plus a -2, and that's going to give me a +2. I'm going to add a -7 with a -4, and that's going to give me a -11. Notice again, we have a new row 1. So row 1 changes. Row 2 stays the same. So just bring down all the entries. I got -3, 4, and a -7. So all of these matrices, if we go back, are equivalent. They're all equivalent to one another. They're all equivalent to the original matrix that we started this off with right here. They're all equivalent to these matrices. So I'm going to just simply erase this here. You should have it. It's already digitized, I guess. But that's kind of a quick description of what you need to do with our game plan. Convert the matrix to another matrix, a row echelon form matrix, using what we call elementary row operations, EROs for short. The first one is we can interchange any two rows. The second one is we can multiply a row by a non-zero number. And the third one is we can add any two rows together. But notice again, when you add rows, a row, one of the rows is going to change and the other stays the same. All these matrices are equivalent. Now, let's finish the problem. So what you guys have in homework is this. You created the augmented matrix. We got 1, 2, -1. Let's augment this with 3, 1, positive 2. Remember what we need to do. We want 0 in this position. Okay, so here's what we're going to try to do. If you really pay attention to this, I'm going to change the color here. I got 1 in that first entry, and I got 3 in the second entry. The only way I can change an entry is by adding rows. So let's notate that. The only way I can change that entry, and I'll rephrase this, I can change it by multiplying by a non-zero number. But how do I get this entry to be 0? What we're going to do is we're going to multiply row 1 by a negative 3. What that does is I'm going to multiply every one of these values by negative 3. So negative 3 times 1 is negative 3. Negative 3 times 2 is negative 6. Negative 3 times negative 1 is positive 3. I changed row 1, and I didn't multiply anything to row 2. So this is still 3, and this is 1, and this is 2. Now here's what I was really getting at. Yeah, I can change an entry in a row by multiplying it by a non-zero number. Non-zero simply means not 0. But the only way we can get a 0 is when we have here opposite values. That's the only way we can actually zero out an entry. So I want to zero this entry out here. I want to get 0 there. And the only way we can do that is if these numbers here are opposite in value. One's positive, one's negative, but they are strictly opposite. We are now able to add row 1 with row number 2. So adding row 1 with row number 2 changes the entry in row 2. So notice what I did. When I take the negative 3 and add it with 3 now, and I go back here, row 1 plus row 2. When I add those rows, negative 3 plus positive 3 gives me a 0 in the position that I need. I just now have to accept all the other values. This is what I'm saying. Negative 6 plus 1 is going to give me negative 5. Positive 3 plus 2 is going to give me positive 5. This changed row 2. Only row 2 is going to change, and row 1 stays the same. I have negative 3, negative 6, and positive 3 now. Now, here's what we want to notice here. That what you get here and what you see is a matrix where that entry there, that lower left corner entry, it's column 2, or I should say row 2, column 1. This is in row echelon form. So we rewrote this matrix to 1 in row echelon form. Now you might say, well, how do we use this, or what do we do? We're going to remind you that every one of these values that we got, negative 3, let's get the highlighter. Let's remind you, negative 3 is a coefficient, negative 6 is a coefficient. This is equal to 3. So that first equation, by the way, is, looking right here, negative 3x minus 6y equals 3. The second equation is, now let's take a look again. We have this 0. So in some ways we can say that's 0x minus 5y equals positive 5. We're going to use these entries and put it back into our system form. Now 0x is really going to be 0. So this portion here is gone. And that's why it's so important for you to get a 0 in this entry point. This special entry, the lower left corner, row 2, column 1 must be 0. And now we can solve the system. And you might say, well, how do we solve the system? I'll write this down. Solve the system. And how we do that is going to be using algebra. That negative 5y equals 5. We can solve for y. So I'll go through this detail. Divide both sides by negative 5. We get cancellation. And now y is going to be positive 5 divided by negative 5, which is negative 1. And in all my classes, I remind students, and they say, use now back sub. Use back sub to find the other value, the other variable. You know x is negative 1, so I can go back to any equation. I'm saying y is negative 1. I could go back to any equation and replace y with a negative 1, a negative 1. Well, the second equation is just going to give me a true statement. The first equation, if you notice now, will be negative 3x minus 6 times negative 1 is positive 3. And negative 3x, let's get this here, negative 3x, negative 6 minus 1 is positive 6, equals 3. We're going to subtract 6 from both sides, and you end up with negative 3x is 3 minus 6, or simply negative 3. You're going to divide both sides by negative 3. Cancels. You end up with x being negative divided by negative is a positive. So we solve this system, and what this means is that these two linear equations intersect at a point. The point is 1, negative 1. And this is using the matrix method. And I went through all the gory detail, somewhat of a little review of what we discussed in class to solve this original system by the matrix method. Again, it's the shorthand for the addition method. You're just using all the coefficients and you're zeroing out that x entry. So nevertheless, that's number 1 in the homework. Let's use these methods to do now number 3. Number 3, we have the system x plus 4y equals 1. And we have 3x minus y equals 3. We're going to create the augmented matrix. Remember, coefficient here is 1. So I got 1, and then I got 4. 1 and 4. And then I got a 1. 1, 4. Augment this with 1. And then I have a coefficient 3, and this is negative 1. 3 and negative 1, and then a 3. 3, negative 1, 3. Okay. Again, we want that left-hand corner. We want this entry to be 0. So I'm going to compare these values here now. I got positive 1, I got positive 3. They need to be opposite. So I'm going to multiply negative 3 with row 1. I'm going to get a new matrix. So negative 3 is going to be multiplied to every value here. This gives me negative 3, negative 12, negative 3. The second row stays the same. 3, negative 1, positive 3. Okay? Now, what we're going to do here is add the rows like we did in the prior example. So we're going to take row 1, we're going to add it with row number 2. Row 2 changes. Make sure we notate the change. So notice what happens now. Maybe we'll leave these till later. Let's focus on this. Row 1 entry with row 2 entry in that first position. Negative 3 plus 3 is going to give me a 0. Don't forget to put the answer in row 2. Now, negative 12 plus a negative 1 gives you a negative 13. Negative 3 plus 3 gives you a 0. Entries in row 1 stay the same. Negative 3, negative 12, negative 3. We have a matrix in what we say echelon form, or simply row echelon form, because this entry here, that key entry, is 0. Now, use these coefficients to rewrite your system. Negative 3x minus 12y is negative 3. And we can say 0x minus 13y is 0. Well, 0x, this portion here, gives us simply 0, or it's really not there. So we have negative 13y equal to 0 to solve, and we're going to now divide both sides by negative 13y, or negative 13, sorry. We get cancellation, and 0 divided by negative 13 is 0. Use back sub. Plug back in y equal to 0. Now notice the first equation. We have negative 3x minus 12 times 0 is negative 3. Well, 12 times 0 again is, like any number times 0, is 0. So get negative 3x going to be negative 3. Divide both sides by negative 3. Negative over a negative is a positive. So my solution here, or point of intersection, is 1, 0. Number 5. 2x plus y is 1. 4x minus y is negative 7. Let's create the augmented matrix. 2, 1, 1. 4, negative 1, negative 7. Again, those entries are the coefficients, or I should say, these are the coefficients we use. Notice we did take 2, positive 1, positive 1, 4, negative 1, negative 7. Now, again, we need 0 in this position. And if I add row 1 with row 2, we get 2 plus 4, and that gives me 6. That's not 0. We need values that are opposite. A way to achieve this is to multiply row 1 by the value negative 2. That means I'm going to multiply every entry in row 1 with the number negative 2. I end up getting negative 4, negative 2, negative 2. The entry in the next row does not change. I get an equivalent augmented matrix. Now, if we notice that when I add row 1 with row 2, remember, the second row will change. We're going to take again row 1 plus row 2 And notice this time I do get the 0. So when I keep adding, remember the second row changes. Negative 2 plus negative 1 gives me negative 3. Negative 2 plus negative 7 does give me negative 9. I have a new row 2, but row 1 stays the same. So I have negative 4, negative 2, negative 2. We've actually gotten 0 in this position. We got a matrix in row echelon form. Okay, let's use this. Here's what this means. Negative 4x minus 2y is negative 2. Negative 3y is negative 9. When I solve negative 3y being negative 9, I divide negative 3 to both sides. Goes away. Negative divided by a negative is a positive. So y here is 3. So wherever there's a y, I can replace that with a 3. Here, here. Notice that first equation is negative 4x minus 2 times 3, and that'll equal negative 2. Negative 4x minus 6 is negative 2. Add 6 to both sides, you get negative 4x is negative 2 plus 6 is positive 4. Divide both sides by the negative 4. Negative 4's cancel. And we get x going to be negative 1. This is the solution or point of intersection, or the solution to our system, however you want to call this. This is number 5. Number 7. 3x minus 2y is negative 6. 6x minus y is 3. We're going to create our augmented matrix. 3, negative 2, negative 6, 6, negative 1, positive 3. Go back and double check. 3, negative 2, negative 6. 6, negative 1, positive 3. These are the entries. We're now going to try to get 0 in this position. We're going to multiply negative 3 with row 1 to change row 1. That means every entry here, 3, negative 2, negative 6 in row 1 gets multiplied by that negative 3 value. Negative 3, oh, we should say, I'd take that back. Let's get this correction. Let me double check. It is 3. We started, yeah, okay. So it's going to be negative 2. This is the reason why you notate everything and say we're going to multiply everything by negative 2. Now notice why we had to do that, or why I noticed the problem. You see, negative 2 times 3 is negative 6. That negative 6 needs to be added with the negative 6 down here, or the positive 6 down there, to zero out that entry. So that's what I noticed by notation here. Negative 2 times negative 2 is positive 4. Negative 2 times negative 6 is positive 12. All the other rows, or I should say entries in the second row, remain unchanged. This is our new matrix. We could now add row 1 with row 2 and make sure that row 2 changes. The reason we do this, let's keep this to the end, is if I notice I take this value plus this value, I get the 0 for my first entry in row 2. So row 1 plus row 2 gives me that 0. 4 plus negative 1 will give me a positive 3. 12 plus 3 gives me a what? 15. The first row remains unchanged. Negative 6, positive 4, positive 12. We're now going to consider the fact that we do have a matrix. This entry here is 0. This matrix is in row echelon form. Okay. Now that it's in row echelon form, we're going to recreate the system using these coefficients. We have negative 6x plus 4y equals 12. I got that 0x plus 3y equals 15. And by now you may realize and say, well, this just gives me a 0 here, which means it's gone, and you're correct. Okay. So now we use the fact that 3y is 15, and we're going to solve this for y. Divide both sides by 3. We get cancellation. 15 divided by 3, this is 5. So I can replace this 5 now for y in any equation that I have. The first equation becomes negative 6x plus 4 times 5 will equal 12. Negative 6x plus 20 equals 12. So I'm going to subtract my 12, or I should say 20, from both sides. So what we get negative 6x will be 12 plus negative 20. Looks like it's negative 8. Okay. Divide both sides now by the negative 6. Negative 6 cancels. I get x going to be 8 divided by 6, because a negative divided by a negative is a positive. So let's double check to make sure everything is okay here. 6x plus 4. Okay. Negative 6x plus 20 is 12. Okay. So let's reduce this fraction. We get x going to be 2 times 2 times 2 and 2 times 3. X will be here 4/3. My solution is 4/3 and 5. Okay, it looks like that was number 7. That brings us to number 9. Negative x plus 3y is negative 14. X minus y is positive 6. So I have negative 1, positive 1, negative 1. We have negative 1, 3, negative 14, positive 1, negative 1, positive 6. Okay? So these are the entries for my matrix, and then let's notice that the game plan will be to try to make this first entry there 0. Now we're very lucky because we can notice that negative 1 plus positive 1 will give us a 0. So that means is row 1 plus row 2. We'll change row 2 and we get the 0 where we need. Negative 1 plus 1 is 0. 3 plus negative 1 is positive 2. Negative 14 plus 6 is negative 8. Row 2 changed. Row 1 staying the same. negative 1, 3, negative 14. We're going to use these entries to write our system. Negative x plus 3y is negative 14, and 2y is negative 8. So using 2y is negative 8 by dividing both sides by that 2, we obtain y being negative 4. Wherever there's a y, I can replace it with a negative 4. So that first equation is negative x plus 3 times negative 4 is negative 14, or negative x minus 12 is negative 14. We can add 12 to both sides. Negative x is negative 2. It's negative 1x. Divide both sides by negative 1. So negative 1's cancel. And let's see what you get. Negative divided by negative is a positive. So we get 2, negative 4 as a solution here. Okay. Number 11. Negative 3x plus 2y equals 4. 4x minus y is 3. We're going to create an augmented system. Negative 3, positive 2, an augmented matrix. 4, negative 1, 3. So we're going to create an augmented matrix for our system. Let's be correct there. Okay, remember, we want to get a 0 in this entry. So this problem is a little different because of the fact that if you notice, let's change some colors here. Oh, I don't know, let's use green, I guess. If you notice that these two numbers are not multiples, I should say, they're not multiples of one another, like some of the examples we had prior. But that's fine. That's okay. Here's what we're going to do. Let's notice this here. Let me get rid of the colors. Here's what we can do. We're going to take 4 and multiply that 4 with every entry in row 1. We're also going to take, let's change this, negative 3. We're going to multiply every entry in row 2 by negative 3. So I'm going to change now 2 rows here, somewhat at the same time. So we're multiplying by opposites here. We're going to use this value, negative 3 times every entry in row 2, and we're going to use 4 times every entry in row 1. Let's get rid of all this. Let's see the effect. This is kind of a nice trick. So notice what we get. I'm going to take every entry here in row number 1. Here's row 1, negative 3, 2, and 4. Multiply every value by 4. Let's see what it gives us. We get 4 times negative 3, which is negative 12, 4 times 2, which is 8, and 4 times 4, which is 16. I'm going to now take every entry in row 2, and I'm going to multiply it by 3. 3 times this, 3 times this, 3 times this. We get positive 12, negative 3, positive 9. So the effect here really is to make these values in that first position opposites. And that's the idea. And this trick you can use every single time. So we're going to make this opposites. We're now going to add row 1 with row 2, and row 2 will change. So I get negative 12 plus 12 is 0, 8 plus negative 3 is 5, 16 plus 9 is 25. Row 1 stays the same. Negative 12, positive 8, positive 16. This is our new matrix, and it's in row echelon form. So let's use the coefficients here. Our system is negative 12x plus 8y equals 16, and simply a 5y equals a 25. So using the fact that 5y is 25, we're going to solve this equation. Divide by 5. Y is 5. We're going to use that back sub. Wherever there's a 5 or wherever there's a y, we're going to use that 5. Here's what we end up with. Negative 12x plus 8 times 5 is 16. Negative 12x plus 40 is 16. Subtract 40 from both sides. You get negative 12x is 16 minus 40 is negative 24. Divide both sides by negative 12. We'll get x equal to positive 2. So these are my solutions here. I should say this is the solution, a solution. The point of intersection is at 2, 5. X is 2, y is 5. And that's number 11. So let's go down to 13 now. X plus 5y is negative 3. Negative 3x minus 15y is 9. So let's create our augmented matrix. Remember, there's a 1 here. So we get 1, 5, negative 3, negative 3, negative 15, 9. Okay. 1 and negative 3 are multiples of one another. So we're going to multiply 3 with row 1 to change the entries in row 3, meaning let's take that back. We're going to change every entry in row 1, and we're going to multiply every entry by positive 3. So 3 gets multiplied to everything you see here. 3 times 1 is 3. 3 times 5 is 15. 3 times negative 3 is negative 9. And I get negative 3 here, negative 15 here, and positive 9. Okay. We're now going to add row 1 with row 2. And remember, we're going to get a 0 in this entry. So let's take a look. Row 1 plus row 2. 3 plus negative 3 gives us that 0. 15 plus negative 15 gives us another 0. Negative 9 plus 9 gives us yet another 0. And that first entry stays the same. So I have 3, 15, negative 9. So let's go back and discuss again what we know when we see this situation here. Zeros across the board there. Now what I want to say is focus right here. What that means is, yes, if I said to you, let's go back and write this as a system, 3x plus 15y is negative 9, That means 0x plus 0y is 0. Remember that these entries are 0. So that I get 0 equals 0, which is what we're looking at here. Now, this is a true statement. Okay? 0 is 0. And if you remember from the discussion in class, what that really means is we had the same line. The same line means there's infinitely many points of intersection, or there is infinitely many solutions. And typically, how we'd express this is, in set notation, we say, here's an ordered pair x and y such that pick any of the equations that you have. These points have to satisfy this equation for x and y. This is another way of saying that there's infinitely many solutions. They happen to be the same line. Anyway, it looks like that was number, what was this, 13? Let's take a look at number 15 now. Number 15. 4x plus 5y is negative 2. 8x plus 10y is negative 4. Let's create our matrix. 4, 5, negative 2, 8, 10, negative 4. Again, we have the multiple situation, so we're going to multiply 2 with row 1, and that's going to change row 1. So every entry here, 4, 5, negative 2, gets multiplied by a 2. So we get 8, 10, negative 4. 8, 10, negative 4. Actually, we need to do a negative 2 here. Negative, negative, and now a positive. All right. So, if I add row 1 again with row 2 changes. Remember, the idea is to get a 0 down here. And negative 8 plus 8 does give us that 0. So we're going to keep adding. Negative 10 plus 10 gave us a 0. Positive 4 plus negative 4 gives us a what? A 0. The first row stays the same at negative 8, negative 10, positive 4. Again, we notice that a row of zeros. This here is a true statement. 0 is 0. That means infinitely many solutions are, instead of all points x and y, such that, pick any of the original equations, doesn't matter. 4x plus 5y is negative 2. Infinitely many solutions. Okay, so this is how we do number 15. So that leads us to 17. 17. 3x minus y is 4. 3x minus y is 5. Let's create the augmented matrix for the system here. Okay. Well, we're going to have to multiply negative 1 to row 1 so that all the values are opposite, and when I add, I get a 0 in that entry. So remember, every entry in row 1 gets multiplied by -1. Here's what we're going to get. -3, +1, -4. +3, -1, +5. Row 1 added with row 2. Gives me a 0 entry in this corner. 0, 0, +1 now. The top row stays the same. -3, 1, -4. Using these coefficients to rewrite our system, we get -3x plus 1y is -4. 0x plus 0y is 1. Notice what's happening here. Yes, these values here are 0. This is a 0. This is a 0. And I get 0 equals 1. That's a false statement. Being a false statement means there's no solution. That means these lines, by the way, were parallel. There is no point of intersection. And if you're looking back at the book for set notation, I'll put that in black formally, you'll see this as an answer. And that means that the solution set is empty, meaning there's no solution here, because really the lines are parallel. And that happens when you have a false statement. You have the same line when you get a true statement there. So the thing to look out for really is right here. If you have a false statement there, 0 equals some number that's not 0, like a 1 or a -2 or an 8 or a 1/2. There's no solution. The lines are parallel, and empty set symbol is what you can write down as an answer formally. And that was number 17, and that leaves us now to 19. -5x minus plus 2y is 8. -10x plus 4y is 20. Let's write this augmented matrix. So -2 multiplied to row 1. Notice what will happen. Every entry here. -10, +2, +8. We get multiplied by -2. I get 10, -4, -16. And I get -10, 4, +20. Take row 1, add it with row 2. You're going to change row 2. 10 plus -10 gives you a 0. -4 plus +4 gives you a 0. -16 plus 20 gives you a 4. First row did not change. 10, -4, -16. Notice this. 0 is 4. This is a false statement. That means the solution set is empty. You can just see the symbol in the back of the book. These lines were in fact parallel. And that's number 19. Is that 19? Looks like it's 19. Yeah. Okay. That leaves us to 21. 21. We have x minus 3y is negative 4. 2x minus 6y is positive 8. If we create the augmented matrix again, there's a 1, 1, negative 3, negative 4, 2, negative 6, positive 8. So what we're going to do here is we're going to multiply negative 2 to row 1. We're going to change row 1. Every entry in row 1 gets multiplied by the negative 2. Okay, I end up with negative 2, positive 6, positive 8. Second row remains unchanged. So now, remember, we're trying to get a 0 in this entry. So row 1 added with row 2, we're going to change row 2. This gives us a 0, 0, 16. Row 1 stays the same. And again, we notice we get a false statement here. No solution. Empty set symbol. The lines happen to be parallel. There is no point of intersection. And that's how we solve a system of two equations and two unknowns. Notice that brings us up to 23, which we did in class as well. We have 2x minus y plus 4z is going to equal negative 3. X minus 4z is going to equal 5. Six x minus y plus 2z is positive 10. We're going to create here our matrix, the augmented matrix, the coefficients. So let's take a clear look here, a close look here, and notice that 2, negative 1, and now a 4 here, this is 3 equations, equals negative 3. So I'm going to have 2, negative 1, 4, negative 3. That's my first row. And then I say, okay, well, there's a positive 1 there, so I got my 1. But what's missing here, and I'll put this in red, is the y term. So I can put 0y. Now I have a coefficient. And so the second row will be negative 1. Let's make sure we're using the appropriate colors, I guess. Okay, this is negative 4, positive 5, 1, 0, negative 4, positive 5. And we're augmenting this. Last row, 6, negative 1, positive 2, positive 10. 6, negative 1, positive 2, positive 10. Here's my augmented matrix. Let's draw it a little nicer. Okay. Now, remember here, this is 3 equations, 3 unknowns. So we're going to try to convert this matrix to equivalent matrix, one that's in row echelon form. A row echelon form matrix will look like this. where typically we describe this as 0, 0, and 0. So we want to actually, in the first column here, make these values equal to 0. So every entry below that first entry in column 1 must be 0. And then in the last row, second column, we're going to make this 0. So this is a matrix in row echelon form, and we're going to have to convert this top matrix in blue to this form. Now there's a game plan here. You must do it in this way. Make this entry first, make this entry 0 second. So we have to get that entry 0 in that first position like we've been doing. And then below that, make this entry 0. This is new. We got a second entry to make 0. And then finally, this is the third entry here that we need to make 0. And it must be in this particular order. That is, make this entry first 0, this entry next 0, and finally 0 again. And this is going to be the game plan for reducing our matrix to 1 in row echelon form. Now remember, there's some pretty good strategies here, and this is what I want to do. Using elementary row operations, we can interchange rows. So what I want to do now is this. Let me erase this here. Okay, it's going to be in our notes. This is what we really want to do. Make these entries 0. Row echelon form. I want to remind everybody here that, let's change this here if we can. This whole thing is row 1. Okay, this is row 1, and then this is row 2. I remind you that this is row 3. So we're going to have probably a lot more strategy here to make these entries 0. And what I'm going to do here is I'm going to interchange row 1 and row 2. I'm going to write that in red. Interchange row 1 with row 2. Now let's take a close look and see what those rows are. Gone, gone, gone. This is what I'm going to get. That means these values here are going to be in my first row. 1, 0, -4, and 5. 1, 0, -4, and 5. Row 1 entries are going to now be 2, -1, 4, -3. 2, -1, 4, -3. The last row stays the same, so I got 6, -1, 2, and 10. 6, -1, 2, and 10. All right. Now the reason being I did it this way is because, remember the game plan. We want this entry 0 and we want this entry 0. I can actually change two rows at one time. So I'm going to say if I multiply -2 times row 1, that's going to change. Well, let's see. Yeah, we could say -2 times row 1. And then I'm going to add it with row number 2. That's going to change row 2. Now this is a little bit new for people. This is the first time I'm going to use this. We can do this. Let's be careful about what we're doing though. Let's note that we have to go with the idea that we're going to take a multiple of row 1, -2 times row 1. We're going to change row 2. And what I'm also going to do here for you guys is I'm going to multiply -6 with row 1. And I'm going to add it with row number 3. So I'm going to change those two rows. What's changing here? I'm going to get a new row 2. And I'm going to get a new row 3. And they're going to be all multiples. Or I should say not multiples, but they're going to zero out these entries. Let's see how this works. Now we're going to have to be very careful here. Okay. This is my notation now. So let's erase some of these things. And let's remember what changes here. Row 2 changes. Row 1 is staying the same. So what I do here in a 3 by 3 case, and that row 1 stays the same, is I'll just write row 1 down. 1, 0, -4, +5. There's my row 1. It's staying the same. What's changing is row number 2, row number 3. So let's be careful here with this now. For row 2, remember, I take the constant, -2, and I multiply it to row 1, and I add it to my row number 2. This is what this means. -2, -2, -2, -2 times every entry in row 1. And I'm going to add those new values and put them in row number 2. So let's do this slowly. -2 times 1 is -2. Added to this 2 now. -2 plus 2 gives me a 0. -2 times 0 is 0. Plus -1 is -1. -2 times -4 is +8. 8 added to 4 gives me a 12. -2 times 5 is -10. Added to -3 is a -13. This is my new row 2. I'm actually using two operations. I'm using elementary row operation 2 and elementary row operation 3, meaning I'm taking a multiple of a row and adding it to another row. And we could do that. And that's how I got a new row 2. So let's erase this here and try this to get the same approach. To get a row number 3. Remember, all the details were discussed in the in the lecture, so we're just going over homework. So let's take a look. -6 times row 1. So again, I'm going to multiply every entry in row 1 with the number. This time it's going to be -6. And once I get those values, I'm going to add it to row 3. So let's go with this carefully. -6 times 1. Okay, let me go back. -6 times 1 is going to be -6. So -6 plus 6 gives us a 0 in that entry. So I say to you again, let's go back every step. -6 times 1 plus 6 is 0. -6 times 0 is 0. Plus -1 is -1. -6 times -4 is +24. Plus 2 is +26. -6 times 5 is -30. Plus 10 is -20, it looks like. Let's double check. -6 times 5, -30, plus 10 is -20. There we go. Our new augmented matrix. So we have a new tool here. We could take a multiple of one row and add it to another row. We can kill two birds with one stone, and in this case we killed more than two birds with one stone. We actually killed almost 4 birds here with one stone. So I can go to these equivalent matrices. Now, don't forget what we want to do here. We're trying to get a 0 now in this position here. So we want to get a 0 down here. And then here's what we're going to do now. We're going to do the same trick. I'm going to take -1, I'm going to multiply it with row 2. I'm going to add it with row 3. And let me be clear with my notation. -1 times row 1, and we're going to add it with row number 2. This is going to give me, this is going to be not what we do. Row 2 and row 3. This will make a 0 in this entry down here, which is what I want. So let's go through the details here. We're going to be careful here. Remember, row 3 is changing. Since row 3 is changing, I'm going to just copy the entries for rows 1 and row 2. They're not changing, so I'm going to try to keep everything clear here. The only thing that's changing is row 3. Okay? Now, let's go through the details of how that's going to work. Let's erase this. Let's erase this. Let's erase this. Let's go through the operations here. Okay? My new entries I'll put in red. Now, remember, -1 times row 2 added with row 3. So, we're going to multiply. Let me notate this. -1, -1, -1, -1. -1 times 0 plus 0 is 0. -1 times +1, or -1 times -1 is +1, plus a -1 gives me a 0. -1 times 12 is -12, plus 26 is +14. -1 times -13 is +13, plus -20 is -7. Okay. This is a row reduce echelon form matrix. Notice we get what? 0, 0, 0 here. And let's erase some of these things here. This is what we want to do. We can use now these coefficients and say we got x plus 0y minus 4z is 5. -1 times y plus 12z is -13. We get 14z here is -7. And you can say, what about the rest with these zeros again? Well, notice again, with all these zeros here, what happens? We get a 0, a 0, a 0, a 0. So wherever there's a 0, we might as well just simply erase. It's not even there. We can now solve this by using back sub, or we should start with 14z is -7, so we can now divide both sides by 14, and we'll get z being -1/2. So wherever there's a z, I can replace it with a -1/2, but we're gonna use back sub. So use back sub and go back. Z is -1/2. What that means here is -y plus 12 times -1/2 is -13, or -y minus 6 is -13. Add 6, and what do you get for y? You get -y is -7. Divide both sides by a -1, and you end up with y being +7. So if we go further again and use our back sub, let's go back to the first equation. Z is -1/2, and now it looks like it doesn't matter what y is because y here is missing. So here's what we're going to get. X minus 4 times -1/2 is 5. Our x plus 2 is 5. Subtract your 2, and And we end up here with x being positive 3. So we get the triple 3, 7, 1/2 as our solution. This is our point of intersection in 3 space. So this is what we discussed in class. This is the technique. We solved a 3 by 3. Okay, here's number 25. We got 3 equations and 3 unknowns. We're going to create the augmented matrix. Let's consider the coefficients here. We're going to notate that positive 1, positive 2, negative 3, 9, 2, negative 1, positive 2, and negative 8, 3, negative 1, negative 4, and 3. So here's my coefficients. Let's write these coefficients down. 1, 2, negative 3, 9, 2, negative 1, 2, negative 8, 3, negative 1, negative 4, and 3. Here's our augmented matrix. Now, what we're going to do, again, is we're going to multiply. We're going to notice, first of all, that this 1 in that leading coefficient position is valuable. See, I could multiply negative 2 with that 1, or negative 2 times row 1, and add it to row number 2 to change row number 2. Because we want 0 in this first position. And again, that negative 1 is valuable because I could take negative 3 times that row 1 value and add it to row number 3 to change row 3, because I want 0 in this position as well. So I'm going to get zeros below that 1 by using these elementary row operations here. Let's change that color. Now notice I'm changing row 2 and row 3. I'm changing these 2 rows. What that means is I'm not changing row number 1. So since I'm not changing row 1, let's write down the entries. We're not changing this row. Let me write it a little lower. 1, 2, negative 3, positive 9. Now, I'm going to first change row number 2. So I'm going to have new entries for row 2. I'm going to take negative 2, multiply it to row 1, then I'm going to add it to row 2. So negative 2, negative 2, negative 2 to row 1, added to row number 2. So negative 2 times 1 is negative 2 plus 2. I get 0 for that new row 2. Negative 2 times 2 is negative 4, plus negative 1 is negative 5. Notice what we're doing. Negative 2 times 1 plus 2 gives me the 0. Negative 2 times 2 is negative 4, plus negative 1 is negative 5. Then negative 2 times negative 3 is positive 6. Plus 2 gives me an 8. Negative 2 times 9 is negative 18. Plus negative 8 is negative 26. This is how we got the values here for our second row. Now, let's go back and carefully remove the highlights, because we're going to repeat this process. This time, we're going to multiply row 1 with negative 3. Okay, so we're going to use this color here. Negative 3 times row 1 added to row 3. So negative 3, negative 3, negative 3, and negative 3. Negative 3 times 1 is negative 3. Plus 3, we get a 0. So we're going to change row 3, and that first entry there's a 0. Negative 3 times positive 2 is negative 6. Plus negative 1, we get a negative 7. Negative 3 times negative 3 is positive 9. Plus a negative 4, we get a positive 5. Negative 3 times 9 is negative 27. Plus 3, we get a negative 24. Okay. So this is our new matrix, and it's augmented here. Okay. Now, if we remove some of these highlights here, gotta be careful when I remove highlights. We're gonna notice that these two entries got a -5 in row 2 and a -7. I want a 0 now for this entry. So in order to get a 0 there, we're going to have entries that are opposite in that position. Now, what I'm going to do to make the entries opposite, I'm going to do this. I'm going to change row 2. I'm going to multiply 7 times row number 2. And then -5 times row number 3. This will change row 2 and row 3. So I'm going to copy my entries in row number 1. And let's go through the process now. Okay, let's use the same color format. I'm going to have a new row 2. 7 times row 2. So for every entry in row 2, I'm going to multiply it with a 7. Now let's see what we get. 7 times 0 is 0. 7 times -5 is -35. 7 times 8 is 56. 7 times -26 is -182. And that's for row 2. Row 3 is -5 times row 3, so I'm going to multiply every entry here in row 3 by -5. Now let's erase some of these things so we don't get confused. So -5 down here, -5, -5. Okay. 0 times our new row, -5 is 0. Negative times negative is positive. -25. Positive 120. We are now ready to take row 2 and add it to row 3, which will change row 3. We have opposites in this position here. Remember, we want to zero this out. So row 1 and row 2 will not change, so I'm going to copy down these values. 0, -35, 56, -182. I'm going to get a new row 3. Okay. Now let's go back. Row 2 plus row 3. 0 plus 0 is 0. -35 plus 35 is 0. 56 minus 25 looks like it's going to be 31. -182 plus 120 is -62. Okay, we now have all the information we need. This is going to give us a system. If we use these coefficients, we get x plus 2y minus 3z gives us 9. -35y plus 56z gives us -182. 31z is -62. So we're going to solve this. 31z being -62. Divide both sides by 31. We get our cancellation. And z now will be -62 divided by 31, or z is -2. So I get to go back and use back sub and replace this z with a -32 here. Now we can replace wherever the z with a -32. The second equation becomes -35y plus 56 times that -2 is -182. -35y minus 112 is -182. add your 112, negative 35y becomes, looks like it's negative 70. Divide both sides by the negative 35. We'll get y is positive 2. So if y is positive 2, we can now replace wherever there's a y with a 2. So the first equation now is x plus 2 times 2 minus 3 times negative 2, and that will equal 9. We're going to find the x value by plugging these values back in, and that's a 6. So we get x plus 10 is 9. I'm going to subtract our 10 from both sides here. We now get x is negative 1. So the ordered triple is negative 1, positive 2, negative 2. This is our solution. We're done. This is number 25. (27) 3x minus y plus 2z is 0. X minus y plus 2z is negative 4. Negative 2x plus 3y plus our z is negative 7. We're going to create our augmented matrix using these coefficients: 3, negative 1, positive 2, and 0. 1, negative 1, positive 2, and negative 4. Negative 2, positive 3, positive 1, negative 7. And we can augment this with a straight line or a dotted line. Now I'm going to interchange row 1 and row 2. So I'm going to have 1, negative 1, 2, and negative 4. 3, negative 1, 2, and 0. Negative 2, 3, 1, negative 7. Interchange. Row 1 and row 2. Now I interchange these rows because of the fact that I have that 1 there in that leading coefficient position, which means when I go try to zero these two entries out again, it'll be really easy to do, very easy. Negative 3 times row 1 added to row 2, and positive 2 multiplied to row 1 added to row 3 to get a new row 3. Okay, let's see what we can do. Notice again that we're not changing row 1, so we're going to have our entries: negative 1, negative 2, 2, negative 4. So negative 3 times row 1 going to be added to row 2. Okay. Let's go through the process. Now we're going to get a new row 2. So negative 3 times 1 is negative 3. Plus 3, we get the 0. Negative 3 times negative 1 is positive 3. Plus the negative 1 is 2. Negative 3 times 2 is negative 6. Plus 2, negative 4. Negative 3 times negative 4 is positive 12. Plus 0 is 12. That's our new row 2. We're going to multiply 2 with row 1 to add it to row 3 to get a new row 3. Let's go back and carefully remove our highlights. Okay. Two times 1 is 2, plus a negative 2, 0. 2 times negative 1 is negative 2, plus 3, we get 1. 2 times 2 is 4, plus 1, we get a 5. 2 times negative 4 is negative 8. Negative 8 plus negative 7 is negative 15. Now there's a couple of things we could do here, but I'm going to interchange here. Row 2 and row 3. Here's what we have. 1, negative 1, 2, and negative 4. 0, 1, 5, negative 15. 0, 2, negative 4, positive 12. So we want to get now a 0 in this particular entry here. So we can do that by taking negative 2, multiplying it to row 2, and adding it to row 3. So negative 2 here times row 2. We're going to change row 3. Now what that means is row 1 and row 2 are the same. We just need a row 3. So let's see how to do this. Okay. Negative 2 times 0 is 0 plus 0, because we're going to take negative 2 times row 2. We're going to add it to row 3. So this entry is a 0. Negative 2 times 1 is negative 2 plus 2, 0. Negative 2 times 5 is negative 10 plus a negative 4, negative 14. Negative 2 times negative 15 is positive 30. 30 plus 12 is 42. So we get coefficients now here for a system that look like this. X minus y plus 2z is negative 4. Y plus 5z is negative 15. And negative 14z is positive 42. So let's solve for z in this last equation and see what we get. Let's divide both sides by negative 14. So z is going to be 42 divided by a negative 14. Positive divided by a negative is negative, and that's negative 3. Here's my value for z. So I get to replace my z with negative 3. We now have y plus 5 times negative 3 will be negative 15, or y minus 15 is negative 15. I'm going to add 15 to both sides. I'm going to get y equals 0. So we're on our way. We can replace this y with a 0 and this y with a 0. The first equation now becomes the following. X minus 0 plus 2 times negative 3 is going to be a negative 4. X minus 6 is negative 4. We're going to add our 6 to both sides, and we end up with x being positive 2. So we have 2, 0, negative 3, as the solution here for our 3 equations and 3 unknowns. So let's look at number 29 now. 29. We have 2x minus 3y plus 5z is 27. X plus 2y minus z is negative 4. 5x minus y plus 4z is 27. So when we create this matrix here, let's use the coefficients. 2, negative 3, positive 5, 27, 1, 2, negative 1, negative 4, 5, negative 1, 4, positive 27. Okay. Again, as you can guess, I'm going to interchange row 1 and row 2. And you say, why? Because I have this leading coefficient here. I want this to be my top leading coefficient so I can zero everything out very easily. So let's rearrange or interchange row 1 with row 2. That means I have 1, 2, negative 1, negative 4, 2, negative 3, positive 5, positive 27, 5, negative 1, 4, 27. So, we're going to multiply negative 2 with row 1 and add it to row 2 to get the new row 2. See, that 1 will help me get zeros in this position easily. I can now take negative 5 multiplied to row 1 and add it to row 3 to get a new row 3. So let's take a look at the entries. Row 1 will stay the same, so I'm going to keep these values. What will change is if I multiply negative 2 with row 1 and add it with row 2, I get a new row 2. So negative 2, negative 2, negative 2, negative 2. Let's remove these zeros here. Let's do our arithmetic. Negative 2 times 1 is negative 2 plus 2. We get a 0. Negative 2 times positive 2 is negative 4 plus negative 3. We get a negative 7. Negative 2 times negative 1 is positive 2 plus 5. We get a positive 7. Negative 2 times negative 4 is positive 8. 8 plus 27 is a 35. Negative 5 times row 1 will give us a new row 3. So we're going to get a new row 3. Let's erase the highlights. And let's go through the process. Remember, negative 5 to row 1 now. So, negative 5 times positive 1 is negative 5, plus 5 gives us a 0. Negative 5 times 2 is negative 10, plus a negative 1, we get negative 11. Negative 5 times negative 1 is positive 5, plus 5 gives us a 10. Negative 5 times negative 4 is positive 20, plus 27 gives us a 47. Let's double check. Okay, so let's double check to make sure we're okay. Okay, looks like we're fine. One, we're going to write down the entries of our matrix here. 1, 2, -1, -4, 0, -7, +7, 35, 0, -11, 10, +47. And notice what we want to do here this time is get 0 down here. So we're going to have, let's recall that these two values, they need to be opposite. So to make them opposite, we're going to do the following. Multiply 11 times row 2, which will change row 2. And then multiply -7 with row 3 to change row 3. Row 1 stays the same, so I'm going to copy all those entries down for row 1. Okay, let's see what happens here now. Remember, 11 is going to be multiplied with row 2. 11, 11, 11, 11. Let's remove these highlights. And here we go. 11 times row 2 gives us a new row 2. So 11 times 0 is 0. Oops. We get 0. 11 times -7, -77. 11 times 7 is +77. 11 times 35. Make sure we know what 11 times 35 is. We get 385. Now, let's change row 3. Row 3, multiply -7 times every entry here. That'll give me a new row 3. -7 times 0, we get 0. -7 times -11, +77. -7 times 10 gives us a -70. -7 times 47 is -329. Okay. So now we have 1, 2, -1, -4, 0, -77, +77, 385, 0, 77, -70, -329. We're now going to change row 3. We're going to take row 2, and we're going to add it to row 3, which will change row 3. So notice though, if we change row 3, row 1 and row 2 stay the same. So I'm going to keep the values for row 1 and row 2. Row 2 plus row 3 gives me a new row 3. Alright, let's see what we get. 0 plus 0 gives me a 0. -77 plus +27 gives me a 0. 70 plus -70 gives me a +7. 385 plus a -329. So 385 minus 329 gives us a 56. Here's our new augmented matrix. So we're going to use these coefficients. We now get the system x plus 2y minus z is -4, -77y plus 77z is 385, Then we get 7z will be 56. So if 7z is 56 and we divide both sides by 7 here, we get z here to be 8. Negative 77y plus, let's be careful, these 7's look like z's. 77 times 8 is 385. See, we can replace our z's here with 8 everywhere. So let's see, 77 times 8 though, we get 616. So let's be careful here. Negative 77y plus 616 is 385. We're going to solve this for y. Subtract our 616 from both sides. You get negative 77y is negative 231. So if I divide now both sides by the negative 77, we get y is positive 3. So that y value is 3, so wherever there's a y, I can replace it with a 3. Now notice what that first equation becomes. We get x plus 2 times 3 minus what? Z, which is 8. Okay, and that's going to equal negative 4. I'm looking up here. So that'll equal negative 4. Okay. X plus 6 minus 8 is negative 4. X minus 2 is negative 4. I'm going to add 2 to both sides. We get x to be negative 2. So I get negative 2 for x, positive 3 for y, and it looks like z is positive 8. So it looks like our z is okay. Here's a solution, another ordered triple. These three lines intersect at a point, and that's number 29.